The history of the development of conventional digital technology can teach us a lot, from the strategic importance of Bletchley Park in shortening World War II to the importance of ecosystem and the development of Silicon Valley. It also points to the ultimate emergence of a dominant design. And once that's with us, it's relatively hard to displace. CMOS first emerged in the late 1970s, and it's still with us today. We were pleased to work with the NATO Innovation Fund on gaining and sharing insights into the quantum sector, given its importance to defence, security, and the resilience of the alliance. We took a structured approach, not based on opinion, but on GQI's proven set of frameworks that allow us to analyse the quantum market systematically and in a long-term commercial context. Working with NIF, our approach was to challenge QC developers to extend their usual roadmaps all the way to a system capable of breaking RSA 2048, a cryptographically relevant quantum computer. This proved to be key. Time and again, forcing the large system view brought crucial scaling challenges into clear focus. Even a million physical qubits is not a large-scale system if you're depending on surface code error correction. Cryptanalysis, including breaking RSA 2048, is an important application in its own right, but it's also a marker for the scale of system that can really be expected to deliver a number of other high-impact use cases. There may also be commercial opportunities along the way for near-term systems. We don't dismiss those. But our contention is that it's a Shor-capable platform that has a good prospect of becoming the dominant design for qubit technology. And the impact of that may not have to wait for the end of the journey. When it's clear that one technology has an advantage on the road, then investment is likely to start to drain out of competing qubit ecosystems. Everyone has modules, but the key question is, are those modules part of a scalable strategy? Now, this isn't just 2-qubit gate fidelities. The whole error model matters. Speed of operations also matters. Measurement in particular matters. We have to stand up a realistic code cycle and an effective logical cycle. And crucially, for modular scaling, we need couplers or interconnects that can coherently connect modules together. This has been neglected in far too many roadmaps. That needs to change. Quantum error correction and fault tolerance are red hotbeds of innovation in the sector. This is difficult stuff. We don't dismiss the possibility that the surface code may still be the way this gets done. It's our most proven approach. But less than half the players we spoke to in depth still have that as their plan A for truly large-scale systems. A new wave of innovation is offering much higher encoding rates and lower universal gate set overheads. If one of these new schemes can be stood up and made to stick, it could be very disruptive for current sector scaling assumptions. Really, there are two quite different high-level architectures out there. Some players are building out monolithic arrays of qubits, perhaps with scalable modules, but ultimately a monolithic array. Others are building a variation of distributed quantum computing, either pure photon-based or matter qubits plus photons. Leave your classical analogies on the shelf. This is pure quantum-on-quantum battle, and you need to get your head around it. There are a lot of very talented, innovative teams out there. But the truth is, no one has an easy path on this. There are challenges. And so the important question is, what profile of risk should an investor prefer? We argue that it's better to take the biggest risks up front rather than leave money tied up against a gotcha somewhere down the road. The problem is that too often the sector doesn't seem to have focused this way round, instead rewarding short-term roadmap priorities that show some progress and so justify the next raise. No one current team has all the best ideas and all the best talent. We think there is a major roll-up opportunity coming. But it's going to take the right industrial leadership and capital leadership to make that happen. It's also going to take informed government to support it going through.